Hi everyone, welcome to episode 8. So today we're going to be working some more on the endless terrain system we started last video, just basically integrating it with the map generator and adding in some basic threading so that it doesn't freeze up our game. So to start with, I'm just going to head over to the map generator script, and I'd like to extricate this code for drawing the map in the editor and just put that in its own method. So let's go public void draw map in editor and just paste that code in there. So now we're going to need a way to get the noise map and the color map from the generate map method. So we'll need to create a struct that can hold these two bits of information. So let's go down to the bottom here and just create a public struct, maybe call this something like map data. And this will need a 2D float array to hold the height map, and then a 1D color array for the color map. And we can just hit Command I to insert a constructor. We'll just select the two variables here that we want to be initialized. And then we can go up to generate map and make this return a map data struct. So just then at the bottom, of course, we need to add return new map data, and we'll pass in our noise map as well as the color map. Okay, so up here we can now create a new map data variable. Map data equals generate map, and then we can just replace all of these with map data dot height map, and similarly map data dot color map, and once again map data dot height map. And then I believe there's actually one hiding off the edge of my screen here. So just replace that map data dot color map as well. All right, so I'd just like to now remove the public from the generate map method. I'm actually going to rename this to generate map data instead, to just be a little bit more accurate about what it's doing. And then we can save that and go into Unity, where we should be getting some complaints from the map generator editor, since it can no longer access the generate map function. And we actually want to change this, of course, to be the draw map in editor function now. So let's just replace that in both cases. Let's quickly talk about how we're going to be implementing threading. So the whole point of the threading, of course, is that we can spread the calculation of the map data and the mesh data over multiple frames so that it doesn't freeze our game up while it's processing all of this. So say our endless terrain class wants to get the map data from the map generator class. It obviously can't expect to receive the map data back immediately, since it's being calculated over multiple frames. So in the map generator class, we'll have a void method called something like RequestMeshData. This will take in an action parameter called the callback. So in the endless terrain class, when we request the map data, we'll be passing a method in as a variable, and this method we might call something like onMapDataReceived. So the callback variable in the requestMapData method refers to this onMapDataReceived method. Once we've finished calculating the map data, we can call the onMapDataReceived method and pass in the calculated map data. So to expand on this requestMapData method a bit, all this will be responsible for doing is starting the map data thread. Once the map data thread has got the map data, it can't call the onMapDataReceived method directly, because if we call a method from inside of a thread, then it gets processed on that thread as well. And the reason we don't want this is simply because we'll be doing stuff inside of the onMapDataReceived method that is only allowed to be done inside of Unity's main thread, such as working with meshes and with textures. So instead what we do is we add the map data along with the callback to a queue, and then outside of the thread, in say the update method of the map generator, we go through that queue, and whenever there's an item in the queue, we call the callback and pass in the map data. So that's essentially how this is going to work, and we'll just have pretty much an identical system for the mesh data. Alright, so let's go into the map generator again, and we're going to need to say using system so that we get access to actions, and then using system.threading so that we can use threads, of course. And now let's create a public void RequestMeshData. And as we discussed, it will take in an action of type mapData. The type just meaning this is the type of parameter that the method expects. And we'll call this our callback. All right. And then let's just create a void mapData thread. And this will take in that same action. So we're going to create a thread start delegate. You can just call this our thread start, and this is going to represent our mapData thread with the callback parameter. So we'll set this equal to delegate, and then we'll say mapData thread, and we'll pass in our callback. All right, we also need a semicolon at the end of this brace. And then we can simply say new thread, and that takes in a thread start, so we'll pass in our thread start. And then we can call start on that thread. All right, so this method is now running on a different thread, and we can say mapData is equal to generate mapData. And remember how I said if we call the method from inside of a thread, then this method will now be executed inside of that same thread as well. And then we're going to want to add this mapData along with the callback to a queue, as we discussed. So we're going to need a struct that can hold a mapData variable and a callback variable. Okay, so let's just go down to the bottom here. And inside the mapGenerator class, I'm going to create a struct called something like mapThreadInfo. Now remember, what we're currently doing now for the mapData, we're going to want to do again for the meshData. So it would be helpful to make this struct generic so that it can handle both mapData and meshData. So this will have a public action of type T. We'll call that the callback. And then also a public variable of type T for the parameter. All right, you can just hit Command-I and say we want those two variables to be initialized. Since this is a struct, we should really make these variables read-only because structs should be immutable, meaning that once we create them, we can't change the values of the variables. I'm just going to do that for this struct as well. Just change these to read-only. I'd do it for the terrain type as well, but then these variables won't show up in the inspector, sadly. And we can get around that, but don't want to get too sidetracked right now. So we're going to want to now create a queue for our mapData thread info. So let's also just add using system.collections.generic. And we can then create a queue variable of type mapThreadInfo, which is of type mapData. And we can call this our mapData thread info queue. Just set that equal to a new queue. And then over here, we can say mapData thread info queue.enqueue. So we'll be adding a new mapThreadInfo of type mapData, and we'll pass in our callback as well as the mapData. Now, one thing that we've got to be a little bit careful of is, since we're running this on a separate thread, our mapData thread info queue could be accessed at exactly the same time from multiple different places, and it's not going to like that very much. So what we'll do is we'll use the lock keyword, and we'll say lock mapData thread info queue, and just enclose that all in braces. And all that means is that when one thread reaches this point, while it's executing this bit of code, no other thread can execute it as well. It will have to wait its turn. Next, let's create a update method. So in here, we're going to say if the map_data thread info queue has got something in it, in other words, the count is greater than 0, then we're just going to loop through all of the elements. So we can say for int I equals 0, I less than map_data thread info queue.count, I plus plus, and we're going to want to say map thread info of type map_data, and we can just call this our thread info is equal to the next thing in the queue, so we just call dq, and then we can say thread info dot callback, and we're going to call that callback with thread info dot parameter. Okay, so if we now head over to the endless terrain class, in the terrain chunk constructor, we're going to want to be able to access the map generator. So for the sake of convenience, let's just go up to the top here and create a static map generator reference. And in the start method, we'll just assign that map generator equals, say, find object of type map generator. Then let's create a void on map data received. So we'll take in map data. And then in the constructor, we can say map generator dot request map data, and we'll pass in our on map data received method. Okay, let's just for now do a little print out in here. We can say print map data received. All right, let's test it out. So just wait for that to compile and press play. Okay, so as we can see from our little map data received printouts, it does appear to be working. So let's head back into MonoDevelop. And now that we've received the map data, we're going to want to use that to generate the mesh data. Now you might wonder why we're not just getting the mesh data directly and skipping this step. And the reason is in the next episode, when we're setting up our level of detail system, we're only going to want to generate the different level of detail meshes when they're actually required. So we'll first fetch the map data, and then we can use that to generate the level of detail mesh that we need. So in other words, it's not necessary now, but it will be necessary next episode. So we're no longer going to be wanting to just draw this primitive plane. So let's just change this to new game object. We can call this terrain chunk. And we're going to want to add a mesh renderer and a mesh filter component to that. So let's just say mesh renderer up at the top here, and same thing for mesh filter. And then we can say mesh renderer is equal to mesh object.add component, and we'll add mesh renderer component. And similarly, mesh filter is equal to mesh object.add component of type mesh filter. So just remember the add component method returns the component that it adds, which is why we can do this assignment. So now we'll have a void on mesh data received. So that will take in mesh data. And when we receive the mesh data, we can just say mesh filter dot mesh is equal to mesh data dot create mesh. All right, let's save this and go into our map generator. So we're going to want to basically recreate all of this except for mesh data instead of map data. So let's say queue map thread info of type mesh data. Call this our mesh data thread info queue is equal to a new queue. And then we'll want to have public void RequestMeshData. This is going to take in map data as well as action mesh data callback. And then we're going to want a void for the mesh data thread. So we'll take in the same parameters. And then we can say mesh data is equal to the mesh generator dot generate terrain mesh. We'll pass in our height map from the map data we've been given. So map data dot height map. And then we can also pass in the height multiplier and the height curve along with the level of detail. Okay, so then we're going to want to do the same thing where we lock the mesh data queue, and then we can say mesh data thread info queue dot enqueue new map thread info of type mesh data, and we pass in our mesh data. Well, actually, it's first the callback and then the mesh data. All right. So then we can just do this same thing in the update method. If the mesh data thread info queue.count is greater than 0, then we do a loop for int I equals 0, I less than however many elements are in the queue, and then map thread info of type mesh data is equal to the next item out of the queue, and then we use that to call our callback and pass in the thread info parameter. Alright, so let's head over to the endless terrain script, and let's replace this printout with a call to mapGenerator.requestMeshData, give it our map data and our onMeshData received function. Alright, so now since we're no longer using a plane, but actually our terrain mesh, we no longer need to sort of modify the scale. So let's just remove that line. And let's also allow this constructor to take in a material. So we can say meshRenderer.material is equal to the material we've been given. And then somewhere up at the top here, we can have public material map material. And we can just pass that in when we create a new terrain chunk. Alright, so let's save, go into Unity, and let's just head over to our materials folder and just drag in the mesh material. And okay, let's hit play. Okay, so as you can see, some pretty wild things are happening. Our mesh generator clearly isn't enjoying being threaded, and it's creating these crazy spikes. Thankfully, however, this isn't too hard to fix. Let's just head over to the mesh generator script, and the thing that's causing all this craziness is actually our animation curve, the height curve. It turns out, I don't know what sort of optimizations it's doing behind the scenes, but when we're evaluating it from different threads at the same time, it's returning incorrect values. So one way we could fix this, which is not the way we're going to use, but we could say lock height curve, so that when we're using the height curve, no other thread can access it. And you can see this would fix our problem. Just press F to... Where have these things gone? Here we go. As you can see, this fixes the problem. The reason we're not going to do it this way, though, is that while this is locked, all the other threads are just having to sort of sit around and wait for it to finish, which isn't really optimal. So what we'll do instead is at the start, we'll create a new animation curve, call this height curve, and I'll just call this one here underscore height curve to differentiate. This will be equal to a new animation curve, and we'll just pass in underscore height curve dot keys. So now that each thread has got its own height curve object, we don't need to worry about locking it anymore. So save that and just confirm this is working quickly. It does appear to be. Of course, at the moment, these are all just the same mesh being repeated over and over, but in the next episode we'll add on the texture and make sure that all the offsets are working so that we get one continuous terrain. And also implement the level of detail system as I was talking about. So until then, cheers.